All right, so we're doing integration. This whole new stuff is all about integrals, which is also integration, also called antiderivative. They use all those terminologies, so make sure that you know them all. And what an integral is, well, first of all, let's go back and review. What's a derivative? The slope of the tangent line at a given point. Now, I just told you guys I'm taking an advanced math calculus class. I've been having to find the slope of a tangent line, but now it's in 3 dimensions instead of x, y. I now have an x, y, and a z. So like if I had a balloon here and had a dot on that balloon, I'm supposed to be telling you what the slope of that tangent line going through the dot on the balloon would be, which gets pretty complicated because there's actually an infinite amount of them if you think about how many different directions you can come in off a curve to hit that dot. So there's certain things you have to do in this. So the longer you go, the more advanced you get. But so derivative is the slope of a tangent line at a given point on a straight curve. Now, the integral is always going to be the area between the graph of the function. So if you look at my example here, I drew that red deal right there, that red function, and the x-axis. So we're going to be finding the area of that. And this is where we're going to start, is problems that look a little like that. You did this in geometry class. Now, I probably could have made this so it looked a little prettier. But I also want to talk about, do you see this funky looking symbol right here? That symbol, which I guess I should get my thing so you people at home can see what I'm talking about. This symbol right here, that funky little symbol, is the integral symbol. That's integration, antiderivative, could be any of those. What does that look like? What letter? S. And the reason it looks like an S is because, like I said, we're accumulating, we're getting the sum of all the areas under the curve. So if you were back in geometry class and you saw a problem that looked like this, and I wanted the area from the red down to the blue x-axis, what would you do? What would you do to find the area from the red down to the blue axis? Anybody? Yeah, I'd make geometric shapes. So what I would do is I would go from here and I would try to draw that straighter. Come down here, draw that line. I'd probably take this and extend this thing on over to here and come down like this. And then what would I do with these geometric shapes? I'd find the area of each one, and then how would I get the area of the whole thing? I'd add them all up. So that's why this integral symbol looks like an S, because I'm taking the area of the sums underneath this curve. And when you write this, if you look at this, I made that look too much like an S because it really doesn't look like an S. It's kind of a skinnier deal, more like that. But if you look at this, I'm putting 0 to 3 here because this x value is 0. Going out here to this 3, I'm finding the integral, or the sum of the areas, from 0 to 3 on the x. So if you look here, I said these are the intervals, which are the x values that I'm looking at. So I want the area from 0 to 3 in this my picture. Does that make sense to everybody where that came from? And then I'm going to take and find the area of those. So you need to know the area of a triangle, which you should know from geometry. You need to know the area of a circle. You need to know the area of a rectangle. You need to know the area of a trapezoid. Well, some of you may not know the area of a trapezoid, so I'm going to give that one to you right here, but you will not be given this anymore. It is, I'm going to write it maybe different than you saw back in the old day. Base 1 plus base 2 times the height, all divided by 2. That's the area of a trapezoid. So you need to know all of those area formulas. Now, how do I know? Does anybody remember how I know what base 1 and base 2 are when I look at it? When I look at a trapezoid, does anybody remember what those are? The bases?
They're different sides.
They are different sides, but how do you know which sides? They're the sides that are what?
Parallel.
Parallel, that's right. So remember, these are the parallel sides. And then this height is the distance between the parallels. Okay? All right, so I'm going to come over here. What is this first object? And this isn't the only way you could do this problem. You could break it up into other geometry figures, but I'm breaking it up into only 3. What kind of figure would this first thing be?
trapezoid.
It is a trapezoid because this and this are parallel, and your trapezoids are all going to look that way. Your bases are going to be vertical. And so that makes this is going to be my height. This h is 1 because from 0 to 1 is 1. And then this base is 1 and this base is 2. So when I start figuring out my formula, I'm going to get base 1 plus base 2, that's this 1 and that 2, times my height of 1, all divided by 2. So there's the first part. Then I'm going to go to this next part. What did I make right here? That's a rectangle. Do you see this one right here is 2? And this is still 2 right here. So this is going to be plus 2 times 2 because a rectangle is base times height. And then plus, what do I have up here?
Circle, a semicircle.
I have a semicircle. I hope we all know that the area of a circle is pi r squared. So I'm going to get pi. And what's my r here? I made it so it didn't work so pretty. 1/2. So I'm going to take my 1/2 and square it. And I'm going to take and divide that by 2. Why am I dividing pi r squared by 2? Because it's only half a circle. It's a semicircle. Now, if this problem is on your test, it's probably going to be a multiple choice problem, and you're probably going to have to simplify. So this would be 3/2 plus 4 plus 1/4 pi divided by 2 over 1. So you got to flip that 2 over 1 upside down. So this would be 3/2 plus 4 plus pi eighths. And then you'd want to get common denominators. So when you did that, you're going to make this a 1. You're going to multiply this one by 4 over 4, which would give me 12/8, plus multiply this one by 8 over 8. That would give me 32/8 plus pi-8. So this would end up being, what is that, 44/8, 44 plus pi all over 8. This is probably how they would write the answer. If this is if it's a free response, you can quit right there. Once you plug them in, you can stop. You could actually quit up here. Remember, you don't have to solve in this class. I told you guys on the last test on derivatives, just show me you know the derivative rule and don't change it. I had one kid, no kidding, he had 5 problems where he did the derivative rule right, and he screwed up his algebra because he tried to simplify. If he missed 5 problems, he would have got all 5 right. Okay? So you do not have to simplify when you plug numbers in. So please be careful. All right. Anybody got a question on it? How many of your thumbs up with finding the area of geometric figures? There will be a test problem on the AP test that'll have that on there. Okay? Now that's what 6.1 was about. 6.2 is about Riemann sums. Oh, let's see. All right, I'm gonna do. Let's go this. This is 6.1. This is in your notes. I've got video of this already, but I'm going to do this problem right here. So this says a particle P moves along a straight path with a constant velocity of 2 feet per second. The graph of v of particle P of t, this means the velocity of particle P at time t, it even has that there, is shown at the left. So this right here is your graph. This is the particle right there. That's the graph of the particle. What is the total distance the particle travels from 0 to 2? Well, we need to know that this is seconds, right? 0 to 2 seconds. And this, they told us up here that the velocity is in, where did it say it? Should have somewhere. Oh, right there, feet per second. So this over here is feet per second. That's my y value for velocity. So what am I going to do to find the total distance traveled by this object? Anybody got any ideas?
Area.
That's right. I'm going to do what we just did a second ago. I'm going to make this into a nice little square. So I want to find this area. Well, this is 2 seconds, and this is 2 feet per second. So I'm going to say the integral of 0 to 2 of velocity of particle P of t dt. Now notice, because my function's in terms of t, I have a dt here. So whatever the variable is of the function, that's what goes out here after the change in, so this is the change in time, change in t, is going to be, and then it's going to be 2 feet, nope, sorry, 2 seconds. The base is 2 seconds, times 2 feet per second, the height. So this second and this second reduce. So this would end up being 4 feet. So I would write the answer to this as particle P travels 4 feet from t equals 0 to t equals 2 seconds. Now that's how you would answer it if it was an open-ended sentence. You would answer the whole thing. Yes, sir. I can't hear. Okay, so that's where you write. If you come back over here, when you do an integral symbol, I said right here that when you do an integral symbol, you use the intervals of the x values. So that's telling the x to x. Now, in this case, because t is my variable, these are the t values, and it told me right there I'm starting at t equals 0 to t equals 2, is why the 0 to 2 goes there. Okay? Anybody else got a question? So that's basically what the first section was about. Now, I did all the example problems for you, but you ought to go through and see if you can do them. And make sure you watch my video. All right, now the second part is Riemann sums. And I think he's got in his notes somewhere about Riemann. Okay, Riemann sums. There's actually only 2 that are Riemann sums, really, but there are 4 different things you have to do here. There is something called a left Riemann sum. There's a right Riemann sum. And then this isn't really a Riemann sum, but there's a midpoint, and there's a trapezoidal. And the trapezoidal is not really called a Riemann sum, but we put them all together because they're all the same. They're all estimating. Riemann sums are what you're going to use to estimate. Because, now I just told you that what I'm doing right now is I'm going to have to be doing this for surface areas. So I'm going to be finding volumes under surface areas. Okay? We're going to get the volumes later in this class. It's one of the last things we do, but it's not as complicated as some of the crap I have. But we got this parabola right here that goes to right there. And it says we want to find the total distance from 0 to 2 again. So again, this is seconds. Although, yeah, it says seconds right there, so that's seconds. And does it tell me what the height is? The gravitational velocity shown on the left. They do not really tell me. I'm just going to keep it the same as the last one. This is feet per second. So I hope you can see that something that tells me that I want an integral here is to get a total distance is I want feet. So you're going to have to take a base times the height, where the seconds are going to cancel each other out. You see that? So this is the same kind of problem. Now, if I draw down my straight line here at 2, I want to find the area of this thing. What's the problem with finding the area of that? There's a curve. Now, do we know how to make a curve of a parabola into a nice geometric figure that we know a formula for? The answer is no. So Riemann came up with a way to estimate the areas. Okay, I'm going to show you how all 4 of these work right here on this problem, except I'm not going to go into the midpoint too much because this isn't set up very well for that, but I'm going to talk to you about it. So one of them, and in your directions, by the way, in your directions, the problem will tell you whether to use what kind of Riemann sum. It'll say a left, a right, a midpoint, a trapezoidal. It tells you what it wants you to find. If it doesn't tell you, you can pick any you want. Okay? So I'm going to do a left Riemann sum. And what we make here is Riemann made rectangles. So we're going to make rectangles because we all know the area of a rectangle. So I'm going to do a left Riemann sum first. And I'm going to say that I want two rectangles. Two rectangles. So here's how you find out the base of your rectangle. The base of the rectangle is going to equal B minus A over N. Okay, so here's what A is. A and B are your intervals. And N equals the number of rectangles. So my bases are going to equal, in this case, 2 minus 0 all over 2. So this is my N right here. That's my N, and they'll tell you how many rectangles they want. And then my A and my B come from right here. A and B are right there, 0 and 2. So that means each base of my rectangle is going to be 1. Am I going too fast? So I'm going to do, and what this left tells me is I want to do the left height. So if I come over here and I start at the left, I know my first rectangle is going to come over here and down, and that's my base of 1 right there. Because the bases are 1, I got to go 1. Then my second rectangle is I'm going to go from this spot where I just was. I'm going to come up to that spot. I'm going to come over, and that's going to be my second rectangle. So I'm going to plug 0 in first. I'm going to plug 0 in because this is 0. That's a 1. And, oh, wait a second, that's a 2. Sorry. That's a 2, and there's a 1 right here. So to get this height, I'm going to plug 0 in right here into this formula right there for t. So 0 squared is 0. 0.5 times 0 is 0. Plus 1 makes this height 1. So when I estimate this, the estimation, let's see, what do you call this function? B, oh, you call it B of, what's that letter? I can't read it. What's that little letter there between the B and the T? Q. So particle Q here of dt to d, v of t of particle Q, and that's a dt right there. It's kind of not really well written. It's going, and I'm going to put squigglies because I'm approximating it. So my base on this first rectangle is 1 times my height is 1 plus, and now I got to get them over here. Well, this base from 2 to 1, that makes that base 1 as well. From 1 to 2, from 0.1 to 0.2, that base is 1, and now I got to find my height. So my height is the left height, so I need to find this height right here. So how am I going to find that height right there? Anybody?
Plug it into the formula.
That's right. I'm going to take 1 and I'm going to plug it in right there for t. So 1 squared is 1. 1 times 0.5 is 0.5. And 0.5 plus 1 is 1.5. So I'm going to take this times 1.5. Now you could quit right there, but this is going to, if you don't, you can simplify this to 2.5. And this would be feet. And the reason it's feet is because I'm taking feet per second times seconds, and the seconds cancel. So I would say that this particle Q traveled a total of 2.5 feet from t equals 0 to t equals 2 seconds. How many are thumbs up on that? Now, that's an estimate. Now, would this be an overestimate or an underestimate to the actual area? That'd be an underestimate because the rectangles, if you look, there's extra area right in here and right in there that we didn't count, right? So that would be underneath the actual area. Anybody got a question on that? Now, left is not always going to be an underestimate because if I have a graph that's decreasing, if I got a graph that's decreasing and I do a left estimate, that means I'm coming from the left side, and I'm making my rectangles over this way. And by the way, you can make more rectangles. See, that would be an overestimate because I got area in my rectangles from the left that's too big. You understand what I'm saying now? All right, now I'm going to talk about a right Riemann sum. So we're going to change this to right. So what that right means is I want the right heights of these. So my bases are not going to change because these are still ones. These are set. But these heights are going to change because now, come over here and erase this. Now I want to go from this right side. So I would come over to 1 and come down and come over, and that would be my first area from the right. So I want to get this height right here. This is the height I need right there. So what am I going to plug in to figure out that height? Anybody? What's this x value right there? 2. So I'm going to plug 2 in there. 2 squared, 4. 0.5 means half of 4 is 2. 2 plus 1 gives me 3. So going from the right, my first height right there is a 3. Then my next height is going to come from where this touched the line and stopped, is that one. Now, we just got this one, right? It was 1.5, remember that? I can plug 1 in there and solve it again, but that's 1.5. So now I got 3 plus 1.5, so now my total distance traveled by the particle q would be estimated to be 4.5 feet. How about that? Would that be an underestimate or overestimate? That'd be an overestimate because we got extra area showing in the rectangles. So my actual area would be where? Between what numbers? Between 2.5 and 4.5. See, we can narrow it down a little bit, right? Yeah. Are we thumbs up what I'm doing so far? I haven't looked at home. Anybody at home have any questions? Okay, we're going to go and do a trapezoidal next, because trapezoidal is very similar. Okay, trapezoidal, but my area formula is no longer base times height. It's now the sum of B1 plus B2 times H divided by 2. I just gave it to you a minute ago. Maybe I should write it again. Trapezoid B1 plus B2 times the height divided by 2. That's your trapezoid. Okay, so now, go up here and erase this thing. I'm still saying that these are still 1s down here at the bottom. But now I'm going to go up this height, and then I draw a straight line segment to that next dot. And then I go from that dot and I go from, there it is. Then I go from that dot up here to, if I could draw it straighter, it'd be nicer. Come on, straighten it. That is not even looking close to a trapezoid. So, would this be an over or underestimate? What? Let's see. We're got a curve going like this, right? And I got a point here and a point there. If I draw a straight line there, that would be over. Did you say over? Yeah, that'd be an overestimate. But it's closer, isn't it? Isn't that going to be closer than my other overestimate? So I'd come over here. Now I already know this because I already plugged these in. I know that was 1 and this is 1.5. And let's see, 2 gave me 3, didn't it? I think that was a 3, right? So if I come over here, my first trapezoid is this one. So my base 1 was 1. My base 2 is 1.5. My height is 1 divided by 2. And then my second one, my base, that base is this perpendicular right there, which is 1.5 again. Plus 3 times my height is 1 all over 2. And that right there would be your answer. Now we can go ahead and solve this. So this is 2.5 plus 4.5. So this would be what, 7/2? So that area would be 3.5. So now that's still over. So I know I'm between 2.5 and 3.5 now. Now you're not going to do all of these on each problem. It's only going to tell you to do one. Now there may be a problem where there's A, B, C, D to practice them. But I'm just trying to show you all of them. Now I'm going to tell you about midpoint right now. So here's how midpoint differs on this same picture. So we want the area. We still want this area, but now the height would be from the midpoint, which would be at 0.5. What's the height at 0.5? So you'd have a rectangle there, but you want the height at 0.5, and then over here you'd want the height. Now this should still go over to 1. I don't think I drew it over far enough. And then you want this midpoint height, and you'd want that area of that rectangle there, and you do the midpoints for that. Do you see what we're doing? So I'd have to plug I'd have to plug 0.5 in here and get the height, and that'd be my new height. My bases would still be 1s because I'm still doing 2 rectangles. So let's go ahead and do it real quick. So if I plug 1 in there and square it, I'm sorry, if I plug 0.5, that's a half and square half. That'd be a fourth, right? Half a fourth is an eighth. So if I was doing the midpoint formula, my base is still 1 because from 0 to 1 is 1. But now my height is, what I say it was, 1/2 squared, 1/4 times a half is 1/8. 1/8 plus 1, this would be 1 1/8 or 9/8. Plus 1, and then I'd have to do the height at 1.5. So I'd have to plug 1.5 to get my height into here. So 1.5 is 2.25 or 2 1/4. And let's see, what would that be? That'd be 9/4. If I took half of 9/4, that'd be, because it's a 0.5 times that, that'd be half of 9/4 would be 9/8. So that'd be the height I'd use on this one. So it'd be 1. Did that say 9/8 there? Oh, I forgot to add the 1 to it, right? That'd be 9/8 plus 1, which would be 17/8. So you get the idea what you're doing on midpoint? Now I'm going to show you what they normally do on a midpoint is they give you a chart. So they might give you a chart that says this. They might say 0, 1, 2, 3, 4, and that might be your time there. And then your velocity down here, if it said midpoint and we still want 2, we would now have a base. My bases would equal, I'm going to go 0 to 4, would be 4 minus 0 over 2 would now be 2's. So when I drew this, I'd be going from 0 to 2 and out here to 4. But if you know, I want my heights here and my midpoints. So I would go a midpoint up to here, and let's say that's 10. And I would draw this rectangle right here, which would be 2 times 10. And then let's say this at 3, I had a height of 3. So this would be 2 times 3. So this would be 10 times 2 plus 2 times 3. You get the idea? We're using the midpoint height. Okay? All right, I think I'm done unless I got questions. Again, if you've not watched the videos, please watch them. I want you to get out your worksheet 6.2 and start on it right now. Or you might want to go to your 6.1 note sheet and try to do some of those before we get out of here. We got about 10 minutes. So let's start working on those. So if you have questions, you can ask me.